Getting to know the double-sided PCB assembly process, now. Hi viewers. Whether you're a PCB designer or an engineer, chances are you've heard of double-sided PCB assembly. In this video, I'm going to explain the double-sided PCB assembly process and all its nuances so that you can better understand and use it. Let's get started. Introduction to double-sided PCB assembly. A double-sided PCB is a printed circuit board, PCB, with components mounted on both the top and bottom sides. These boards have two layers of copper traces and components soldered on both sides. Double-sided PCBs are the most common type of PCBs and are used in a wide variety of applications, such as automotive, medical, and communication devices. Types of double-sided PCB assembly. There are two main types of double-sided PCB assembly: through-hole and surface mount technology, SMT. Through-hole assembly involves components with leads that are placed through holes in the PCB and soldered on the other side. SMT, on the other hand, involves components with tiny pins that are placed on the surface of the PCB and soldered. Preparing the PCB for double-sided assembly. Before components can be placed on the PCB, the board must be prepared for assembly. This involves cleaning the board and inspecting it for any defects or damage. The board also needs to be checked for any shorts or open circuits. Once the board is ready, the components and solder paste are applied. Soldering process for double-sided assembly. Soldering is the process of attaching components to the PCB by melting a metal alloy. This process is essential for double-sided assembly as it ensures that the components stay in place and make a reliable electrical connection. Components used in double-sided assembly. The type of components used in double-sided assembly depends on the application. Common components used in double-sided assembly include resistors, capacitors, transistors, diodes, and integrated circuits, ICs. These components are available in a variety of sizes, shapes, and packages, so it's important to choose the right ones for the job. Benefits of double-sided assembly. Double-sided assembly provides several benefits over single-sided assembly. The most significant benefit is the ability to place components on both the top and bottom sides of the PCB. This allows for more efficient use of space and can reduce the overall size of the board. Double-sided assembly also allows for more reliable connections between components. The components are soldered on both sides of the board, which makes them more secure and less prone to damage. This makes double-sided assemblies ideal for applications that require reliable connections. Challenges of double-sided assembly. Double-sided assembly does come with some challenges. One of the main challenges is the increased complexity of the process. Double-sided assembly requires more steps and more precise soldering techniques. This can make the process more time-consuming and prone to errors. Another challenge is the cost of double-sided assembly. Double-sided assemblies are usually more expensive than single-sided assemblies due to the increased complexity of the process. This can make double-sided assemblies cost prohibitive for some applications. Quality control in double-sided assembly. Quality control is an important part of any manufacturing process, and double-sided assembly is no exception. Quality control involves inspecting the board for any defects or damage, as well as testing the board to ensure that it meets the required specifications. Automation in double-sided assembly. The double-sided assembly process can be automated using machines such as pick-and-place machines, reflow ovens, and automated optical inspection, AOI, machines. Automation can help reduce the time and cost of the process, as well as reduce the chances of errors. Conclusion. In conclusion, double-sided PCB assembly is a complex process that requires precise soldering techniques and quality control. The process can be automated to reduce the time and cost, as well as reduce the risk of errors. Double-sided assembly provides several benefits, such as increased efficiency and reliability, but it also comes with some challenges, such as increased complexity and cost. I hope this video has helped you better understand the double-sided PCB assembly process. Thanks for reading and happy PCB designing. Visit our website, PCBA.